Hiya! Glad to greet you again in a new Ælis video. We're at number 45 already, and I must say, the amount of videos exceeds my expectations by far. But I enjoy doing these, so as long as that's the case, I sincerely hope you'll enjoy watching. That's the good news. The bad news is the topic we'll be discussing today. I'm sure some of you will immediately start feeling a bit queasy when I say that we'll be talking about
mathematics
today. Before you click away, it's not Ælis' intention to become the language par excellence to do and discuss mathematics in, but we will need some form or fashion of expressing basic mathematical operations. So that's what we'll do today. Before we begin, I'd like to point out that this video will draw from previous videos. These are Lesson 4 about counting and personal pronouns, specifically the counting part, Lesson 6 about the axes of space and time, Lesson 13 about the characteristic and the referent, specifically the part about the referent, Lesson 19 about inward connectors, and video number 25 where we revisited counting and the personal pronouns. Again, this video will build on the counting bit and not the other one. It is possible that if you haven't seen those videos, you'll get confused in this one. Therefore, if you haven't already, I'd like to advise you to go watch all of them and then return here. Now, the fun thing about this subject is that I won't be needing to introduce any new root words to you. Everything we need has already been presented to you, albeit in a different context. No wait, there is one. One new root word we'll need, but just the one, so let's get that out of the way quickly. Please meet this root word, que. Que is the counterpart of ka and means negative number. So in video 4, we learned how aika is 1, eka is 2, ika is 3, and so on. Well, replace ka with que and the numbers turn negative. Therefore, aike is -1, eke is -2, ike is -3, and so on. In all aspects, this root word behaves exactly the same as ka does. So everything we ever discussed about Ælis' number system and the uses of ka also applies to que. Okay? Right, so let's dive in. We'll start with what many agree is the easiest mathematical operator, addition. For expressing addition, we'll need one of two root words, yo or yi, the passivity and target particle, respectively, which we talked about in video number 19. To say, for example, 1 plus 2, in Ælis we'll say either aika, io, eka, or aika, yi, eka. The reason behind why we can use either of these particles has to do with logic, with what io and yi actually mean, and the directions these particles make references in. Io refers backward, yi refers forward. In other words, aika, io, eka means something like 1 to which 2 is applied, or 1 which is subjected to 2, 1 to which 2 is added. Aika, yi, eka means something like 1 which is targeted at 2, or 1 which moves towards 2, 1 which joins 2, something like that. Alright? These root words are interchangeable not only because of what they mean in this context, but all the more because the order of operations in additions itself doesn't matter in the first place. 1 plus 2 equals 2 plus 1, so it matters even less. In mathematical additions, the root words io and yi are interchangeable. Easy, right? Conclusion: if you want to add two numbers, just add io or yi between them. Next, we'll have a look at subtraction. The fun thing about subtracting in Ælis is that we don't have to learn anything new. After all, addition and subtraction are the same thing. If you have no idea what I'm talking about, then you might need to dig deep and try to remember math class, where you were hopefully told that subtracting is nothing more and nothing less than adding a negative number. And that's exactly how we'll do it in Ælis. Subtraction works exactly the same as addition does, only now we'll add a negative number instead of a positive one. As a nice side effect, this means that in Ælis, the order of operations in a subtraction doesn't matter either, just like it doesn't in an addition. This is in contrast to English, where 3 minus 2 and 2 minus 3 are definitely not the same thing. Nice, don't you think? The next mathematical operator we'll look at is division. For this, we'll need the referent particle discussed in video 13, vai. If we put vai in between two numbers, then it means something along the lines of 1 out of 2, 1 over 2. By the way, and this is something I forgot to mention back in video number 13, you can perfectly add other root words to this formulation too. For example, let's add ma for male. Aika vai eka ma means 1 out of 2 men, or half of the men. Alright? So, add vai in between two numbers to express division. Easy peasy. Next in line is multiplication. For multiplication, we'll use the root word at. I generally translate this root word as frequency, though in this context it's perhaps better if we interpret it as iteration, repetition, or number of times. So for example, aika at means one time, or once. Eka at means twice. Ika at means 3 times, and so on. Therefore, ika at eka means 3 times 2, right? No, I'm afraid we're jumping the gun. Because at eka does not mean times 2. If a cardinal number follows another root word, then it becomes an ordinal number. And therefore, at eka means the second time. But then, in this construction, what do we do? Do we give preference to ika at, which means 3 times, or to at eka, which means the second time? Well, we ran into similar issues in video number 33 about partition marker ranks. If compound words like this contain semantic ambiguities like this, we'll usually want to split them up and insert a partition marker. In this case, the target marker yi will be the most suitable candidate. This way, we'll get ika at yi eka, and that can be interpreted to mean 3 times targeted at 2, or better yet, factor 3 given to 2. Ika at yi eka, 3 times 2. Alright? Depending on how you prefer to look at it, you can also simply memorize that at yi can be used to mean multiplied by. We've now gone over the 4 basic operations in mathematics, but there is one more operation I'd like to discuss with you: powers. For expressing exponents, we're going to use the particle tha, which means straight line or dimension. Why specifically that word? Hold on to your seats because I really like this one. Have a look at this. We pronounce this mathematical operation as x to the second. But when the exponent is 2, there is another way to say it: x squared. This is no coincidence. Why not? Well, imagine a line with a length of x. If you now create a square, where all sides are the length of x, then the area of that square is x times x, or x to the second. That's why it is called x squared. It is the length of x, but multiplied by itself because we're working in 2 dimensions. The same thing applies when we add another dimension. We now get x times x times x, or x to the 3rd power. Our square now becomes a cube, whose volume equals x to the 3rd. This is why it is called x cubed. When we take higher powers of x, it becomes impossible to visualize because our world is only 3 dimensions. but mathematicians, physicists, astronomers, and other scientists have no problem assuming the existence of and working with more than 3 dimensions. This is why Ælis doesn't have a problem using the root word da, meaning dimension, for expressing powers. The first 3 exponents can be visualized, the rest can be inferred through analogy. Okay? Now then, how would we say, for example, 2 to the third in Ælis? Well, ika, da, gi, eka. 3 dimensions given to 2. And that's how we express powers. So we've now talked about 5 mathematical operations: addition, subtraction, multiplication, division, and exponentiation. But we're still missing an important piece of the puzzle, the equals sign. For this purpose, we're going to use the root word rai, which means level of similarity. We've encountered this root word on several occasions, and no, it is a class 2, therefore qualifiable root word. We'll turn rai into rai ora to express complete equality, and to that, we'll still add the referent marker vai in order to link the equality to that which follows. And with that info, we're now able to express, for example, 1 plus 1 equals 2 in Ælis. Aika, ji or yo, aika, rai, ora, vai, eka. 1 plus 1 is completely equal to 2. One of the things I like so much about Ælis, and I hope you'll agree, is that for so many things the groundwork is already there. You just have to be resourceful with your puzzle pieces to discover new ways in which you can use them. After all, the only new root word we introduced today was the root word que for negative numbers. But the mathematical operators themselves are all expressed by means of root words that already made their appearance over the course of previous videos, just in other contexts. These root words aren't new. The only new thing is that I've shown you another way of using the same ingredients yet again. Hanai na ora. Thank you for watching.